Managing disks. In this nugget, we'll be taking a look here at managing disks. We'll take a look at two different disk types, primarily MBR as well as GPT disk types. GPT is usually used for larger disks. Also, we'll take a look at basic disks, which use MBR, and dynamic disks, which can allow you to use dynamic volumes. With dynamic volumes, you can use things such as spanned volumes, RAID 0, RAID 1. Also, we'll take a look at disk maintenance, and particularly things such as checking your disk for errors, cleaning up files that you don't need anymore, and defragmentation. As well as how to handle removable storage devices such as USB flash drives. Alright, let's take a look first of all at the disk types you can use in Windows 7. By the way, these are all true of also Windows Vista and Windows Server 2008. With master boot record types of disks, this is actually something that's been true since about the beginning of time with Microsoft Computing. It uses something called a master boot record style of disk. With this kind of a disk, you have to understand that you can use up to 4 partitions. That's an important thing to know about. And the partition types you can use are 4 primaries, called a primary partition. It used to be that you could only boot from a primary partition. That's still true of many operating systems. But with Windows 7, you could also boot from a logical partition, although I don't really see a lot of reasons why you would want to do that. But that's one of the reasons why we used to want to create primary partitions. They're not better than any other kind of a partition. That was just a characteristic, is that you could boot from them. And then, if you didn't want 4 primary partitions, maybe you wanted several drive letters. What if you wanted, 6 drive letters on your hard drive? Drive C, D, E, F, G. Have I gone 6 yet? H? I think that's it. Okay. Well, if you wanted to do that, you could create 3 primary partitions, but that only takes you to C, D, and E. Now what are you going to do for the rest of these? Well, what you could do is inside of the 4th partition, you could create what we call an extended partition, and then inside of that, you could create logical disks, and this could be as many logical disks or logical partitions as you have drive letters. So you could go all the way to Z there if you wanted to. Again, I don't really see a lot of reason to go to too many disks, and for the average end user, you want to keep things as simple as possible. But just, at least theoretically speaking, that's what you could do. So you could go up to 3 primaries, 1 extended. You can always have 1 extended. You can't have 2 extended, for example. And then inside of that extended, you can create a number of different logical disks. Also, the MBR type of a disk maxes out at 2 terabytes. This also has some backup ramifications, although it's not part of the exam. But you'll see this when you go to servers, is that when you try to create a backup using built-in backup products that are included with Windows, such as Microsoft's built-in backup for Windows Server 2008, it cannot back up partitions larger than or up to 2 terabytes. It has to be a little bit smaller than 2 terabytes in order to be able to properly read it and take the backup. So anyway, that's MBRs. Now, GUID partition tables are not, again, necessarily any better than MBR. They're just different. They're designed differently so that they can handle a greater number of partitions. For example, you can have more than 4 partitions on a GUID partition table type, whereas up here with an MBR you can only have 4. Also, with a GUID partition table or a GPT, you can have greater than 2 terabyte storage. In fact, let me see if I can show you an example here. I've got a server over here on my one of my other machines. This is a 2 terabyte partition that I have for my photographs, because I've got quite a lot of digital photography out there, and that takes up quite a lot of space. But I have another disk that I couldn't use an MBR for. And that's my backup disk, and for that one I had to go to a GUID partition table because it's an 8 terabyte drive. And here's where the disk is. This is actually in a RAID array. There's actually several disks in there, 5 disks in there, and altogether they comprise about 8 terabytes total of storage. And this had to be a GUID partition table. This is where I back up all of my data, and that's on a server. And I know it's not part of Windows Server 2000, Windows 7 here, but that's just an example of when you might need to use a GPT. Now, you can convert a master boot record type of a disk to a GPT if you wanted to. Again, I don't really see a lot of reason for doing that, but certainly you could do that. The key there about converting from MBR to GPT, and by the way, you can also go the other direction. Let me put another arrow in here. You could also go from a GPT to an MBR. The key there is that in order to do so, you cannot have any existing partitions on the disk. So I can't really demo that because I've got something on all my disks here. But if I wanted to convert this, let's say it was empty, then I would right-click here, and you can see that it gives me a convert to GPT disk, and that's kind of grayed out right now. But if there's nothing there, I could certainly do that. Likewise, to convert from a GPT to an MBR, it would also have to have no existing partitions on it. Also, you can use a basic disk as opposed to a dynamic disk, which we'll cover next. A basic disk is probably the most common kind of disk you'll see, and if you do just generic formatting and creating generic partitions and simple volumes and things, you're going to be using basic disks. A basic disk uses the master boot record partition table. What this does is it's a table that stores primary and logical disk partition information and allows you to create simple volumes, you would say right here, simple volumes on your basic disks. If you wanted to use the disk part command in order to create a simple volume, then you would type from the command line. You would first of all go into disk part by typing disk part at an administrative command prompt, and then you would type create space volume space simple, and you can also specify things such as the size if you want. In fact, let's go ahead and take a look at a disk here. Here I'm on a Windows 7 computer, and it's a freshly installed computer with only a few things changed in order to make it ready to record with. But I'm going to right-click on the computer and choose Manage, and this is where we can get to disk management. I could have also gone there by typing disk mgmt.msc, and then you can see here that would open up the disk management console. But here I am already in the disk management console, and once I click on this, notice first of all that it identifies a few different disks. Now this kind of swings this off topic just a little bit because I haven't talked to you about initializing disks, but these are 3 brand new disks that I put into this computer that have not yet been recognized by Windows. And when they're initialized, they get a unique identifier attached to them and some other things that Windows can use to identify them. So here's the 3 disks that I installed, and I'm just going to choose to make these MBRs, but I could have also chosen, of course, to make them GUID partition tables as well. MBRs is just more common, so that's just what I'm using. And then I'm going to get rid of this actions pane over on the side because it takes up too much space in this small amount of resolution that we have. Now, once we've gotten this created, here we have a basic disk. It's online. And right now it's unallocated, which is just, no partitions are created. It's not been formatted. Now, normally I just like to use the UI, so I'll just do it that way. I'll just right-click here, choose New Simple Volume, click Next, specify the size, click Next. And because you don't have to use all the size, you can make a smaller than the maximum amount if you want to. And then here's a few different things we could do. Number one, assign a drive letter. I'll tell you one thing that I do is that I'll generally have to be careful about this. For example, if we use thumb drives, then maybe the thumb drive that we normally use is not plugged into the USB port right now. And when it does plug in, maybe it assigns itself drive letter E. So now if I mount this drive letter, or assign this drive letter to this partition I'm creating at drive letter E, then the next time I plug in my thumb drive, it'll have to reassign itself to a different available drive letter like F. This could throw off certain shortcuts I might have created to that thumb drive, or applications that are pointing to it, or most recently used files and applications that had pointed to it, that sort of thing. So for the user side of things, you don't want to confuse them if at all possible with that kind of thing. That's why, in my opinion, I like to prefer to give thumb drives and that type of removable media drives somewhere in the middle of the alphabet, because map network drives start at the bottom of the alphabet, hard drives start up here at the top of the alphabet, so I usually try to put it somewhere down here in the middle. But for our current purposes, it's fine. Notice that I can also mount the following NTFS folder, and what we would do with that is if I had an empty folder, for example, on drive C that did not have any contents in it, no files, then I could mount to that empty folder. I would just browse to it and mount to it. If it wasn't already created, then I could also create a new folder in drive C if I wanted to. And what that would allow me to do is to double click on that folder in C, but in reality, it will take the user to this storage space right here. So to the user, it looks like it's on drive C. In reality, it will actually be on a totally separate drive. So that's just what that would be. Or you could not assign any drive letter or path. Here, I'll just call this, James Drive. Okay, driver, drive. And then I can perform a quick format. Notice that you can also compress it. We don't really see much need for that anymore, but I'll just go ahead and format it for the time being. Now, we've also worked with partitions quite a lot in previous nuggets here, especially when we were talking about imaging and ImageX and all those sorts of things, because a lot of those administrative tasks have to be performed from a command line. But here I'm just going to go to a command prompt, an administrative command prompt. And by the way, if you don't want to right-click on the CMD to choose Run as Administrator, you can also hold down Control-Shift and press Enter, or Control-Shift and click on it, and that will also prompt up this user account control dialog box. I'll just click on Yes to go into the administrator command prompt. Now, that's just a quick tip for you. You don't need to know that for the exam, but Control Control-Shift always brings up the user account control item. I'm just too lazy to right-click on it. I got to save myself some calories there and use a convoluted keyboard combination instead. Anyway, I want to use disk part to create my volumes and also to list disks. I always list disks and list existing volumes first because it's way too easy in this to accidentally select the wrong disk and perhaps clean it or something like that, which would format that disk. That would not be a good thing. So that's why I usually want to look this up this way. And then we can see the first volume that we created has got to be on drive 1, I'm pretty sure. And then you can see here volume 2 is drive E. Now this is sometimes confusing, especially if you work with a lot of disks, because I don't want to clean or format the wrong partition here or the wrong volume. So I take a look at this and I say, is E on drive 1 or on 2 or 3? Well, let's just do this. What we can do is to select volume 2, because I know that's where my drive letter E is. And then I'll usually do this. I'll just do a detail volume. And that will tell me the volume 2, which is the selected one, is on disk 1. So if I want to work with a different disk, I'll work with disk 2. So I'll select disk 2. And then I want to, if it's got partitions or any data on it that I want to get rid of, then I'll just clean. And then again, that just wipes out any existing partitions. Now I need to create partition primary, or I could also have chosen, an extended, but I'm just choosing primary here, and you can type in the whole word primary or abbreviate it there. That either one works fine. And then what you would need to do is to format it. Now, another thing you want to consider here is that in addition to formatting it, I could have also chosen create partition primary, and then I could have put on the end of that size equals, and then specified in megabytes how big I wanted it to be, 500 or something like that. And then it would you just use that much space. Otherwise, if I don't specify, it uses all available disk space for format quick, and that would pretty much be it. So now you can see it's successfully formatted it. If we go back in here, wait a minute. Where is it? Oh, there it is. It's right there. Also, another thing we could do here is to set a volume name to it or set a label to it. But you can also do that if you want to from within this as well. So if I right-click on this and choose Properties, notice that there's nothing up there right now. But I could say, James Other, Other Drive or whatever. So you can see how we can do that within the interface as well as within disk part. So that's how you work with basic disks. Ooh, I just realized something here. This is wrong. Actually, I got this from Microsoft's documentation, but this is incorrect. They say that you can use create volume simple. That's really not true at all. If it's a basic disk, then you create partition. Okay, partition, primary, or extended if you want as well. But it would have to be create partition. Create volume is something used with dynamic disks, which we're about to get to. So this would be correct syntax for that only. So let's talk now about dynamic disks as opposed to basic disks. This is something that is a Microsoft creation, and so it's not something you'll find directly, at least in Linux and so forth. So with this, you have the logical disk manager, or the LDM, and as opposed to the partition table. And what this does is it stores information such as the volume type, the membership, the drive letters, and certain other types of information. But these are kind of the top three. The volume type would be like if it's a RAID 1, or if it's a RAID 0, if it's a spanned volume. Its membership, for example, if it's a spanned volume, then that involves more than one disk or storage space. And so the membership would identify which disks were involved in that spanned member. Okay, we're going to talk also about what those things mean, RAID and spanned and all that here in a little while. But anything that involves more than one disk, it identifies the membership. Also retains the drive letters. This means that if I take it from one computer and its drive letter, Z, and I take it to another computer, when I plug it into that computer, it will also still be drive letter Z unless something else has already used that drive letter, such as a drive mapping for a network drive. Because remember, they start at the end of the alphabet. So if that's the case, then it will just use the next available drive letter. But otherwise, it uses the same drive letters, even if you move it to a different computer. The logical disk manager is replicated to all members, for example, of an array. So again, if I have something like a spanned array, or if I have RAID 1 mirroring, then that RAID 1 mirroring involves two disks and two members. So with this, each of the disks will have information about the other disk. When you move a disk that's a dynamic disk, it will retain again its drive letter and its configuration, so it will remember that it was part of a RAID array, for example. And when you take that disk and you insert it into a different computer, it will show up there as a foreign disk. And if that's the case, then when you see it, I don't know if I have anything here I can work with right now, but if it were to come in that way, it would over here, it would say foreign disk. You would right-click on it, and then you would choose import foreign disk. And that's the way you would work with that if you move it to a different computer. Also, if it goes into a different disk, you may also have to right-click on it and choose reactivate. Okay, rather than just talk through some of those things, I thought I'd just go ahead and show you. So I took some time offline here to go ahead and take a couple of disks that were originally created in a different computer. It's actually on a Windows Server 2008 server, and where it had a mirror. Now I've imported them into this computer so that when I go to disk management, and I'm doing this kind of blind because I haven't tested this out in advance yet, but let's go ahead and see here that we should see a couple of other partitions there, and there they are. Okay, so these are known as dynamic disks, obviously, but they are foreign as well. So what I would need to do here is to import these foreign disks, and you can see here that because of the LDM, the Logical Disk Manager, it knows that there are two disks involved in this set. It's not that they're just two disks that are just kind of lost, and wondering what they're supposed to be doing here. So because of the LDM, they know what's going on. If I want to check out which disks they are, there they show up just fine. And I'm just going to go ahead and bring these in, and it brings in the entire mirrored volume. Again, we'll talk more about mirrors at a later point in time. But that's one of the advantages, though, of dynamic disks, is that they bring themselves in automatically for the most part, unless someone's already using one of the drive letters. And they really work pretty well for that purpose. Now, for real RAID purposes, which we'll talk about here in a little while, probably you're actually going to use hardware RAID, but at least it's available in Windows. And if you use dynamic disks, then you can use dynamic volumes. And that's what I'm saying here, is that dynamic volumes require dynamic disks as opposed to basic disks, which use partitions instead of volumes. All right. Or instead of dynamic volumes. Also, we can use a number of different types of volumes here. Spanned volumes, which use multiple storage areas all combined together. RAID 0, also known as striped. RAID 1, known as mirrors, and RAID 5, known as striped with parity. Now I'm going to talk about those in more detail here, starting with the spanned type of volume. A spanned volume, what that does is you just pile on storage as needed. Let me just quickly show you how we would do that in this interface here. Let me go back up to the previous disk that I'd created. I'm just going to go ahead and delete these volumes. Okay. By the way, even though these are basic disks, Microsoft documentation and verbiage is a little bit confusing because this is a partition. See, it says right there, primary partition. So if I want to delete it, how do I do that? By deleting the volume. So thank you very little for all that confusion. Anyway, so here we go with a couple of different volumes now. Now, if I decide to go ahead and create what we've got going on here, a spanned volume, then what I'll do is create these as dynamic disks. So I'm going to convert these to dynamic disks, and I can just choose, let's say, disk 1. Have I got the right ones? Disk 1 and disk 2. Yeah, let's do that. Okay, so once I've done that, then I can create a new simple volume. And I'm going to quickly go through here and just kind of quickly next finish my way through this. I'll just call this span. Okay, one of the spanned volumes, and click next and finish. And then what I can do with this is, let's say that here I want to go ahead and add additional space that's available. I can do that by right-clicking here, and choosing Extend Volume. Now notice here that when I click on Next, I can choose a different disk. Okay, and I can specify how much of that storage space I want in that other disk. And now I've got a spanned volume where when this disk runs out of space, let's say I'm copying some big files up there, once it reaches 1021 megabytes, it'll spill over into using this disk. In Windows Explorer, they both appear as if they are on a single disk to the user, but this is actually using two physical hard drives. Okay, so that's what we can do with a spanned volume. Also, one thing to keep in mind with this spanned volume is that there is no redundancy at all. So if one of those disks were to fail, which happens an amazingly frequent amount of times, I've had many disks fail in my career, but if I lose just one volume, in that, then all the data gets lost. Okay, you probably can use some kind of third-party solutions that might be able to recover some data for you, but there are often very expensive solutions. You might have to send those disks into a recovery service. Also, with a span disk, there's no performance benefit at all. Some of the other kinds of RAID arrays, it will read or write from multiple volumes at once, thereby increasing the total disk throughput that's available for you. Also, this is very often used just for temporary expansion. So, for example, I might have done that if, and of course I'm using very small volumes so that they create quickly and stuff like that for demonstration purposes. But let's say that I've got this volume right here, and I get close to the end, and then I realize, oh man, I got a big, movie file that I have to copy to this disk, and my boss is expecting it tomorrow. Oh no, I don't have any more storage space, and I can't run down to the electronics store and buy some more. So that's the case where I might span to an additional storage space, but this is not something I want to keep there for very long because I'm running too great a risk if one of those disks fails, then I've lost all the data. So that's probably just until I can get to the electronics store and reconstruct something that would be a better solution. Now, in reality, if you already know in advance that you're going to use 2 disks, like I just did with that spanned volume, I'd probably rather use a RAID 0 volume, although it's still not ideal. This is known as a striped volume, and you still don't get redundancy. So you're probably thinking, okay, James, why would you do this if you don't have redundancy either way? Well, because of the fact that if I'm looking for performance, and that's very often the case with things like video production and things, then I'll get fast read and write performance on a striped volume. And that's because it's able to read and write to both of those volumes, sometimes simultaneously. So, theoretically speaking, it could get up to twice the throughput, although that rarely, if ever, happens exactly like that. But I could get some performance benefit out of this. Now, this is still not ideal in terms of the fact that I don't have any redundancy. You might use a RAID 0 array if you had a regular backup solution, or if you had something like volume shadow copy, or if you had nightly backups, and some other kind of a backup solution going on. But the thing with a backup solution is I'm only going to be able to recover data that was made maybe during, let's say, last night's backup. Anything I've been making during the day could still be lost if I lose a drive. Also, with a RAID 0 striped array, let's just go back over here and try to reconstruct some stuff. I'm going to delete this volume. And when I do that, we're going to see that it frees both of these up again here. But if I now create a new striped volume, and next my way through this, I can choose to add both of these other disks here as well. Notice that, let me scroll this off to the side. Notice that disk 3 is 2 gigabytes in size. These two are 1 gigabyte in size. But that when I add disk 3 in, it only gives me 1,021 megabytes, or a gigabyte. Why is that? It's because when you use a stripe, it can only use the amount of space on each disk equivalent to the smallest one of the members. Okay, both of these members were smaller, so therefore this one had to back down to the smaller size, like these two were. So then I can go ahead and click on next. So what's going to happen is I get the aggregate storage space between all of these. And I'm also going to be able to show you that here in a moment. So let me just go ahead and quickly go through this. I'm not even going to name this or anything. I'll just go ahead and click next, and finish. Of course, it's going to convert these to a dynamic disks, all 3 of these to dynamic disks. And then when it's done formatting, we'll have the volumes here that we can work with. And there it is. Okay, so now when I want to right-click and explore this drive, then we see that this volume here, if I choose its properties, is going to give me 3 gigabytes of space. So that's the aggregate total space available on each one of these 3 members. But again, there's no redundancy. So if this disk were to fail, I'd lose all the data on all of the disks. Now, probably a better solution for any kind of redundancy would be something like a RAID 1, also known as mirroring. These are 2 disks that are exact duplicates of one another. So when you write a file, it actually writes to both of the disks at the same time. That way, if one of the disks fails, then the other one can continue to be used, and this will give you some redundancy. Then if that one of the disks were to fail, then you could pull that failed disk out, replace it with a known good disk, and then rebuild the RAID array. And so that's a pretty good way to work. Also, this gives you pretty fast read performance because it could potentially read from both disks at once, although the write performance is not any faster. Also, you got to realize that this gives you a 50% overhead. So let's say that I have one 1 gigabyte disk here. I know that's small, but let's just say 1 gigabyte. Actually, let's make this 1 terabyte, be more realistic. 1 terabyte, and then 1 terabyte here. Okay, in other situations like spanned disks or something like that, I might have 2 terabytes total storage space here. So it doesn't feel like I've wasted any money because I get a lot of storage space for my disks. However, with a RAID 1 mirror, since they're exact duplicates of one another, then I only get 1 terabyte total space. So that's 50% overhead. Okay, and that's how we reference these disks in terms of the available storage space. Now, if you want to get a little bit more storage space, but you also need to use more hard drives, then you could go with something called a RAID 5 array. This is also known as RAID 5, which is also known as striped set with parity. With a RAID 5 array, what you have is at least 3 disks. You can have pretty much as many as you want, as much as the computer will hold anyway. But you can have at least 3 disks, and one of the members in this RAID 5 array will be a rotating member that stores data or parity about the contents on the other members. Okay, so if I were to take a look at this again, let's take a look at how this might work. Here I've got a disk here, and a disk here. Okay, this has data. I'll say this is the first bit of data. This is also got data. This is the second bit of data. And then this one would have parity, which would have information about data on 1 and data on 2. Okay, so that if if this drive were to fail, then we could reconstruct this disk once we replaced it with a known good one, based on the fact that there's parity information here, and it can reconstruct data 1 up in here. All right. Now this is kind of oversimplified because that's only for a single write. They take turns, kind of in a round robin fashion. This one has the parity data right now, but on the next write, maybe this one will have parity data instead about disk 1. I'm kind of running out of room there, and disk 3 down here. Okay, so that's kind of how this works out in terms of RAID 5. There's rotating parity data about the other members there. This also does give you pretty fast read performance, because you can read from, if you had 3 disks, for example, you can read from 2 of the disks. The one that has parity data, you don't read from that one. That's only, the parity data is only useful in the event of a reconstruction. In the event of a reconstruction. I don't know where I came up with that. Anyway, also, you got to keep in mind that there's going to be a CPU burden on writing. Okay, so if you're writing very large files, very disk-intensive writes, again, such as in graphic arts, streaming media, those sorts of things, and you're writing to a RAID 5 array, well, the CPU has to perform parity bit calculations. It has to know what to write to that parity bit, and it involves some mathematical calculations to come up with that data. So there could potentially be a CPU burden on the writing of the data. If you're just doing normal office work, you're reading small, Word documents, you're checking your email, that kind of thing, you probably won't notice the burden. Now, one place where you will notice the burden is upon resynchronization. This can be a substantial burden on the CPU and the disk. What happens with that is that if you have to reconstruct the drive, then it has to reassemble the data that was on the missing drive, and has to reassemble that on the replacement drive, and it pulls all the parity data off of the other drives in the array. And this is extremely intensive in terms of the CPU and overall disk burden. It's really going to thrash those disks until it's completely resynced. Also, the overhead that you have with this is going to be equivalent to 1 disk. So if I have 3 disks, let's say I have 3 1 terabyte disks, okay, then normally if I were to concatenate all those together, 3 times 1 terabyte, then I would have 3 terabytes, right? Well, with overhead, you lose 1 disk because it's being used for the parity, or the equivalent of 1 disk. So in this case, it would actually have 2 terabytes total storage space there. One thing to keep in mind with RAID 5 as well, this is kind of weird. I got to tell you, I expect that you'll need to know about this for exam purposes. However, you can't use RAID 5 in Windows 7. It doesn't matter if it's Ultimate, Enterprise, Professional, whatever. You can't use RAID 5 in Windows 7, so that's kind of weird. Although as we take a look here, I've gone to my server, and we can see here that I do use RAID 5 here. And the reason why I do that is really financial. This is a RAID array in a Dell server. If I use the Dell card, their hardware card that allows me to use RAID, it's exorbitantly expensive. But in order to support it, they insist that you use only their hardware. So it's a little bit maddening for me, but for financial reasons, I decided to use Microsoft's RAID solution instead. So on a server, I can use RAID 5, and you can see here that that's exactly what I've done, and that's what these are. Now, I also wanted to talk to you about another kind of a RAID, and this is something that is not actually on the exam because you can't do this within Windows directly, but it's very popular in high-end workstations or power users or in servers. What this actually is, it is called RAID 10, but there's no such thing, technically speaking. Actually, what it is it's RAID 0 plus 1, and the way this works out is that you might have this. You'd have to have 4 disks. But what happens is you really start off with a RAID 0 stripe. So that's what we already discussed. Remember, we have data stored on one drive and on another drive. So data might be split up between these 2 drives. Remember, this normally has no redundancy. So that if I were to lose one of these drives, if I had only these 2, then I would lose all of my data. However, in order to accommodate that and to give ourselves some redundancy, now with 4 drives, we can mirror this information. So this data is mirrored to here, this data is mirrored to here, and now what can happen is I can lose that drive, and I could still have a first part of my data, a 1 and a 2 here, and I can still use the data because it's on these 2 disks. Okay. Likewise, I could lose this drive and this drive. I could actually lose 2 disks and still be able to have my data again because I've got these 2 disks available. Okay. Now this actually recently happened to me. I'm using RAID 10 in one of my this workstation that I'm recording on, in fact, right now. But there are certain instances where you cannot lose 2 disks. Okay, and you can see here that if I were to lose this disk and this disk, then I can no longer have any disk to reconstruct both my first data and my second data. Okay, so I'm pretty much out of luck. This actually happened to me last week. It was a total nightmare because I lost both of those, and maybe I'll save that for another story when I talk about Windows backups. But basically the short version is I lost both those disks, and my Windows backup got corrupt. So I was really in a bad situation, but I was able to eventually recover from it. So anyway, this is what we call RAID 10. Not an exam issue, but you will see it more commonly on servers and high-end workstations. I think it's becoming more popular because disks are relatively cheap nowadays, and they're gigantic. So what we have here is, if I've got a 2 terabyte 2 terabyte disks all the way around here. That's 2, 4, 6, 8 total terabytes. But since I've got a mirror going on, I have a total of 4 terabytes total storage that I can have, probably still for not that much money, relatively speaking. Now, when it comes to disk maintenance, there are certain things you have to do to keep your disks healthy. Number one is you can run check disk. This used to be known as ScanDisk in older versions of Windows, not really relevant anymore, but in case you're used to that term, I just wanted to write it up there so you know that. We don't call it that anymore, and if you type check disk, or rather ScanDisk, from a command line, nothing happens because that command does not exist. However, you can run something called a check disk, and I've already done it here in advance. You can also run check disk with a /F, as in Frank, and what that does is it'll check for any errors on the disk and fix those errors. However, if you're running it on the operating system disk, like I did here, as you can see, then it's not able to fix those while the operating system is running. So if you run a check disk /F, let me just show you here, check disk. Check DSK /F. Then it'll prompt you. It can't do it now. Would you like to do it the next time the system restarts? And I would say yes to that. And then before Windows actually boots up or actually loads, then it will run check disk. But you can see here that it looks for in my indexes, my security descriptors, and so forth to see if there's any truncated files, orphaned files, which are ways of saying corrupt files. And if it finds any problems, it can potentially fix them, but very often what it will do is it will take those truncated or orphaned files and it will pretty much kind of put a punctuation mark on those files and reserve those out so that they don't get further corrupted or corrupt other data. But anyway, that's what we do. We can run check disk. You can do the same thing, by the way. Let me go back in here to our disk management. You can do the same thing in Disk Management or in Windows Explorer. Actually, let me just do that. Let me go to Windows Explorer. And if I go to my flash drive here, for example, I can go to its Properties, and in Properties I can go to Tools, and then I can look for Error Checking. This actually is the same as Check Disk. It's just a UI for it. And then it will automatically fix file system errors or scan for and attempt recovery of bad sectors. Any bad sector is a physical defect on the disk, and it will mark it as unusable. Although the recovery is a little bit dicey. It's not always capable of recovering the information, but I'll give it a little bit of credit there and assume that it can. Anyway, that's pretty much the same thing if you do the error checking that we see right there. There's also something you can do called disk cleanup. This is a new feature within Windows. And if we take a look at this, what this allows us to do is to go to Start, All Programs, Accessories, and System Tools. This actually did exist in Windows Vista as well. But it's something that you can do right here. You choose Disk Cleanup, and you specify which disk you want to clean up. What this does is it looks through and sees if there's anything in the recycle bin, any temporary files that are left over, any files that you don't need anymore, potentially, error reports, which can get quite large, and it offers to delete those for you. And most of the time, it's okay to clear those things off and not be concerned about them anymore. And you can see it's going to take a little bit of time to scan through that. Also, once this is done, by the way, you'll see in a moment that it also gives me an opportunity to clean up system files. All that really does, which is right here, it allows me to also do things like uninstall programs that I'm not really using anymore. That would put additional tabs up here. In fact, let me just do that so you can just see what we're talking about there. And there it is. Okay, so now you can see, in addition to things like downloaded program files that I'm not using anymore, any offline files, recycle bin files. This is a new computer, so I don't really have much going on here. But you can see there's a lot of different things that could accumulate some space. I've had 100 gigabytes before that I've had to clean out, but I'm sure a lot of people have had even more. But when you choose the system cleanup, then you can also choose additional options, which allows you to remove programs you're not using anymore, or to clear out any space that's being used by shadow copies or system restore. But you can click OK here, and then just click OK, and it'll free up any hard drive space that that might be able to be reclaimed. Also, if you get low on disk space, you'll get a notification in the lower portion of the screen, and it'll offer to run that disk cleanup for you. Another utility that's very useful is the defragmentation utility. This is also just known as defrag. But as an example, if I go to one of my computers here and right-click on a volume and choose Properties, then I can go to the Tools tab and choose Defragmentation and defragment now. What is defragmentation? Well, when you use your disks, let's say this is a hard drive, and this is a file that I've stored on this. Maybe this is a large graphics file or something like that. Well, and if it's a file that I frequently change, then right now it might be using contiguous space. Your hard drive has an arm on it where this arm has to reach out and physically read, it has a head on the end of it, and it has to read the magnetic data across the hard drive here. Okay? Well, that's pretty easy for it to read when it's all sequential. It just reads it in a continuous stream like this. But if I have to open up this file and save it and close it and save the changes, then it could be that data gets scattered around. Maybe now, let me put a little bit of different color in this. Maybe there's another disk in this space, so that the next time that I want to save space on this file, well, it can't save it there. It has to save it here instead. Now the head has to read from this space and this space, and eventually over time that data can get scattered around, and it can just look like kind of a mess here after a while. So now the disk head and arm has to dance all over the place to read that file now, and to write the data it also might have to write it into non-contiguous spaces. So my my file is now fragmented. This is one of the most significant contributors to overall slowdowns in performance, because the hard drive is always the bottleneck. It's going to perform more slowly than RAM and more slowly than CPU. So I can use the defragmentation utility, and what that does is, as much as possible, it will take these little bits of data and reconsolidate them. And this file here that was in the way, it'll move that over to here instead. I guess I could make that red to make it more clear. It'll move that over here instead, and allow us to recompact and what do you call that? I guess recontiguize all of the data that was there. Also, there's a utility called Disk Keeper. This is actually my preference because it's going to give you better performance. This is not an exam issue, but I just think you should know about it because it's used very often in corporate environments. And if I go ahead and open up Disk Keeper, I'm going to try to show it to you here. Then we can see that we've got some volumes that we can see, and I'm limited in my resolution here, so I may have to just kind of drag this up and show you a little bit more here. But what this does is it allows me to analyze a disk, and it gives you a little bit more of an overall view of what's going on with that disk and whether it's needs to be defragmented. Whereas the built-in defragmenter defragmenter that's included with Windows, it doesn't show you that same data. For example, here on one of my drives, where I've got a lot of virtual machines going on and stuff like that, it shows me that the red space there is all fragmented files and folders. Now, if I did not have Disk Keeper, I could still defragment this disk. You don't have to have this. But this gives you a kind of an overall better view of it. And I'm just recommending this. Again, it's not an exam issue, but you'll see this in a lot of corporations. They use this, especially on their servers. And for the job report here, it tells me whether or not I'm getting a performance decrement or anything like that in this disk. And if I am, I can right-click on it then and choose to defragment. And then it's going to give me a performance increase once all those files have been defragmented. Again, the defrag utility also does the same thing, but Disk Keeper is more thorough and it is able to move files that are not otherwise movable that the defragmentation utility cannot do on its own. By the way, defrag is actually just licensed by Executive Software, which makes Disk Keeper. So it's really the same program. It's just that the one that's included with Windows is kind of de-featured. It doesn't include all the bells and whistles as this one does. Now, also, there's some removable device policies that you should be aware of. Let's take a look at those also. And to illustrate that, I'm going to point to my own USB flash drive right here. By the way, I watched the 60 Minutes story the other day, and the reporter called these things thumbnail drives. I guess they don't know much about computers or something. Anyway, these thumbnail drives have been posing quite a threat to cybersecurity. That's what the story was about. And a lot of users that work in classified divisions in the United States government had taken their home thumb drives and plugged them into their classified computers at work, and they had unknowingly transmitted some kind of a hacker's exploit, and hackers were able to download terabytes of data from classified government computers. It was a very scary story, I'm telling you. It was really quite frightening. But anyway, as a result, classified organizations have now prohibited these entirely. You are not allowed to use these at all anymore. One place that I actually work at sometimes as a contractor has actually filled all the USB ports with JB Weld. Can you believe that? That's the stuff you use to plug radiators with. So that's quite astonishing. Anyway, there are certain policies that you need to work with on these things. One of those things relates to whether or not data is lost or corrupt if you pull this thing out. So for example, what if I'm writing data to this and I didn't realize that there was still data being written to it, and I kind of got in a hurry because I wanted to go to lunch. So I jerked that thing right out of the USB port. Well, if data is still trying to be written to it, I could corrupt that write. So that's one thing to think about there. There's also policies that go along with that. If I go to the properties and then hardware, and then I go to that hardware's properties right here, then we can see that there's a change settings button here and a policies tab. I know that's a lot of clicks to go through, but here's where it is. I could choose to use the policy for quick removal. What this means is that the data will be cached. With data caching, it can put it into a special location in memory and then wait until a free moment before it writes it to the USB flash drive. But the problem there is, it could be kind of held in limbo in that cache for a period of time, and I might not realize that. Now I pull the drive out, and then that data gets orphaned, and it could be potentially corrupting files that are on the disk. That's a couple of different things that are involved in that. If I disable that write caching, then when I choose to write data to that drive, it immediately writes it and does not leave it in cache. So then I can quickly remove the thumb drive and be assured that I still have my data. Alternatively, you could change it to better performance, where it will use the write caching in Windows, but if I use that option, then I am forced to use a different option here as well, which is right down here, and you can see a little symbol for this, which is safely remove hardware. I would have to click on that and then choose to eject this drive. And then what will happen is it will flush the data out that was in cache, flush it directly to that disk, and makes it a priority. And then once it no longer appears here, I can safely remove it without being concerned that there's actually still data in the cache. So anyway, that addresses the why you would want to eject the drive, because you don't want anything to be left in the cache, and when you would want to eject it. It really doesn't address any of the security concerns that I talked about on the 60 Minutes show. And I know what you're thinking, by the way. Only old folks watch 60 Minutes. Well, I'm almost 50, so give me a break, okay? It's conveniently timed at 6 o'clock on Sunday evenings. It's right before my 7 o'clock bedtime, and right after I get back from the Luby's cafeteria for my 4 o'clock senior special dinner. Okay, I don't feel that old, but apparently I am getting old. Anyway, let's also talk here about group policy objects that are available for these types of removable devices. This might be something that, for example, government organizations or any place that doesn't want to have these removable flash drives and anything else that would plug into the USB or FireWire ports as external storage, they can prohibit the availability of those things by using a group policy object. So let's go ahead and take a look at that. Here I've gone to another computer. Let me go over here. And you can see again I've got this USB flash drive inserted in there. Let's say that administration has determined that we no longer want any USB flash drives in our organization. We're concerned about security there. So what we'll do here as an administrator, I'll go into the hardware properties of this particular USB flash drive. And I'll go to Properties. Now, the reason why I want to do this is because I'm going to use something called a group policy object to tell it that I no longer want anything with this hardware ID to be installable in my organization. This is the specific hardware ID for this device. Okay. Now, there's some limitations with this. When I create this policy that I'm about to show you, it will only prevent this specific vendor and this specific exact model of their USB flash drive from being installed. If someone else has a Corsair flash drive, well, that'll be installed just fine. But anyway, at least it's a start. I'm going to show this to you anyway because I think it could be an exam issue. What you can do with this then is I usually just copy this. Okay, you can copy whichever level you want. This is the most specific, and as you go down the list, it gets more and more generic. So I could prohibit all brands of this brand, for example, or any generic disk or any USB storage disk. Okay, I could go as specific or generic as I want. But I'm going to show you that you can be very specific with this if you like, and I'm going to cancel all that out for the time being, and then minimize this. And then I'm going to go to a command prompt here, rather to a run line, and do a gpedit.msc. Now, I've already typed that in and opened it up. And what this is it opens up the local computer policy. This allows me to configure and administer virtually every aspect of Windows. Just about everything. Most of the time in corporate environments, this will be configured in Active Directory. But in the absence of Active Directory, you can also do this on a local computer policy editor. The reason why we normally do this in Active Directory is because I configure the policy once, and then it will apply to, potentially, all of the computers in my organization with one click. Okay, so I can really administer maybe thousands of machines quite easily that way. Now, here I would go to the local computer policy, computer configuration, administrative templates, system, and then device installation and device installation restrictions, and I would prevent installation of devices that match any of these device IDs. And I would go into this and I would enable this policy, and then I would show which device IDs I want to prohibit, and that's where I would then paste in that device ID I had earlier. And of course you can add additional ones here if you like. So then I'll click OK and OK. I'm going to minimize this for the time being, and I'm going to run something called gpupdate force. By the way, this kind of spills over into other areas of administration, but it is very handy for people to know about group policy. Actually, not generic users, but for administrators like us to be able to know, understand, and administer group policy objects. I think it's one of the most powerful tools an administrator has. Anyway, notice that even though I ran gpupdate, I still have the USB flash drive, and there's some drives, there's some stuff right there, and all the files. What's going on here? How come I can still see this thing? Well, this is a little bit of a failing with this particular policy. You see, what happens here is, if the driver was installed at any point in the past, I can still access it. In fact, I could unplug it and plug it back in, and it would still be visible forever. But what I would have to do here is I'd have to also go in here and uninstall this device. Okay. Once I had done that and unplugged it, and I'm kind of off to the side here unplugging it, then when I plug it back in again at a later point in time and try to connect it, look what happens now. It doesn't show up under here under disk drives. Notice that it shows up down here under other devices. It does not show up here under Windows Explorer. And in fact, if I go back into that, this under other devices, if I double click on it, it'll tell me that the installation is forbidden by policy. Okay, that happens to be that group policy object that I just now configured right here. Okay, so I could go back to not configured here, which means that don't give it specific instructions about the fact that I don't want it to run this policy. And now notice that it now shows up here again, and then it also shows up here again. Okay, so that happened pretty quick. Now, another thing you could do, because it's kind of impractical to expect us to run around to each individual workstation and uninstall the drivers for these devices. So what other things could we do there? Well, if you go down under User Configuration, notice that under User Configuration there's Administrative Templates, System, Removable Storage. Is it Removable Storage? I gotta think about it. Yeah, Removable Storage Access. And then there are additional policies down here for various things such as floppy drives, CDs, and so forth. And I could say all removable storage classes deny access, and I could just click on Enabled here. This particular one will deny access to things like these USB flash drives categorically, but it will also do all other kinds of things. Like any of these kinds of storage devices, tape drives, whatever. So you got to be a little bit judicious, but at least it gives you a start in being able to prohibit things such as those types of USB flash drives. Or the more insidious USB thumbnail drives. Now here what I've done is I've gone ahead and updated that policy using GP Update, and I'm going to return to the computer. Gee, it looks like the policy didn't work, because look, there's the USB flash drive. I'll bet if I double click on this, wait a minute, nope, access denied. In this case, you can actually see the device for all practical intents and purposes. It also does show up in Device Manager properly, but you cannot access it. So that's how that policy works. In this nugget, we talked about managing disks. We talked about the two disk types, MBR disks, as well as GPT disks, which, remember, allows you to create additional partitions beyond the 4 that MBR does, as well as the fact that it's used for large volumes over 2 terabytes. We took a look also at basic and dynamic disks. Remember, a basic disk cannot create any of the dynamic volumes that you get with dynamic disks. Dynamic volumes include things such as spanned volumes RAID 0 and RAID 1, although RAID 5 is something you probably should know about. It's not something you can actually create in Windows 7. Also, we took a look here at disk maintenance. We looked at how to clean up the disk for files that you don't really need anymore, defragment the disk, check it for errors, as well as working with removable types of devices. Well, I hope this has been informative for you, and I'd like to thank you for viewing.